Assalamualaikum warahmatullahi wabarakatuh to Doctor. So today our group will present our group assignment for subject analog electronics. Okay, for introduction, FET amplifier is an amplifier that uses for one or more field effect transistor. The FET high input independence allows for the standard flow of RC coupled stage with no loss of gain between stages. FET amplifiers can function with a variety of electronics such as high independence devices, piezoelectric transducer, and capacitance type transducer. The frequency response of an amplifier refers to the frequency range in which the amplifier will operate with negligible effects from capacitors and device internal capacitance. This range of frequencies can be called the mid-range. There are two types of frequency response of FET amplifier, which is low frequency response and high frequency response. So for low frequency response, the frequency response of FET amplifier circuits is determined by exactly the same considerations as for BJT circuits. The lower cutoff frequency is normally set by a source bypass capacitor, and it can be affected by coupling capacitor. For high frequency response, unlike BJT, a device cutoff frequency is not normally specified for a FET. Instead, FET in or high frequency operation have the parameters listed as measured at a specified high frequency. The low frequency parameters are also normally listed. And then for analysis and calculation, for question A. For question A, we need to find the value for GM and GMO, which is a transconductor, which is the formula for GMO is 2 IDSS over VP that we use, and for GM is GMO times by 1 minus VGS over VP. Since the value for VGS are not given, we use graphical method to find Q point, to gain the value for IDQ and VGSQ. Okay, first step for question A, we use the formula of GM, substitute all the value that I have given, and then GMO value is 4 millisiemens. And then we cannot find GM because there is VGS value that is missing. So we need to find VGS value first. To find VGS value, first we use the standard equation, which is VGS equal to VG minus VS. So by using voltage divider rule to find VG, we take the R resistor of gate 2 because it covers the area of VG. And then RG2 over RG2 plus RG1 times by VDD. And then substitute the value, we get the answer is 1.82 volt. 1.982 volt. So we find the value of VS. VS is equal to 1 IS RS. Since IS is equal to ID, we substitute ID, and then the question looks like VS is equal to IDRS. Substitute the value of RS, and then we get the answer is for VS is 1.2 kilo ID. So this is the equation for VGS, which is 1.982 minus 1.2 kilo ID. And next, for graphical approach method, we use Shockley equation to plot the graph ID against VGS. And we use three assumptions, which is ID is equal to 0, ID equal to IDSS, and VGS equal to 0 to find the straight line to get the intersection point. So by using Shockley equation, we make a table which contain VGS and ID. At VGS, we use VP to calculate the value of VGS. So for 0 is equal to 0. 0.3 VP is negative 1.2. 0.5 VP negative 2. VP is equal to negative 4. for IDSS, which is 8 milliampere, IDSS over 2, 4 milliampere, IDSS over 4, 2 milliampere, and 0 is equal to 0. So for the first assumption, ID is equal to 0, uh, the equation of VGS is VG minus VS. In the VS equation is IDRS. Since ID is equal to 0, so there is no VS. So VGS is equal to VG. VGS is equal to 1.982 volt. Second one is ID is equal to IDSS equal to 8 milliampere. So we just substitute IDSS value, and then the value of VGS is negative 7.618. The third one is VGS is equal to 0. So 0 is equal to VG minus IDRS. We rearrange the equation and get the ID is equal to VG over RS. So value for ID is 1.652 milliampere. So after get all of the value, we can plot the graph. And then this is our graph that we have plot. So this is Q point, which we get the IDQ value, which is 2.9 milliampere, and VGSQ is negative 1.5 volt. After that, we just substitute the IDQ value into the VGS equation that we obtained from the uh, VGS equation. And then we get the value of VGS is negative 1.498. So we can proceed to calculate the GM value. And then substitute the VGS value, we get the answer is 2.502 millisiemens. And then next is question B. So question B asks to calculate the height cutoff frequency of FHI and FHO. So we use the formula of frequency, which is 1 over 2 pi r times by c, 2 pi rc. So for FHI is 1 over 2 pi rthi ci, which is input capacitor. So and then for FHO is 1 over 2 pi rtho and co. FHI is for input and FHO is for output. So before that, we don't have value of uh, amplifier gain, which is AV. So we use the formula of AV is equal to V out over V in. So for V out is negative GM VGS, RD parallel to small RD parallel to RD parallel to RL. For V in is VGS. Since RD is infinity, we just ignore RD, and then we just cut VGS, because VGS over VS we can set out. So substitute the value, get the answer is negative 8. So we can continue calculate. So for RTHI, which input resistor, I assume that RA is RG1 or parallel to RG2. So RA parallel to R. So for RA parallel to R, value is 9083.41 ohm. Then the value for the FHI is 625.77 kilohertz. But before that, I forgot that we use formula CI is equal to CWI plus CGS plus CMI to find the value of the input capacitor, and 1 minus AV times CGD to find the value for miller input capacitor. Okay, for the FHO is 1 over 2 pi RTHO CO. So for CO is CWO plus CDS plus CMO, and for miller output capacitor is 1 minus 1 over AV times CGD. So value for CMO is 2.25. Just substitute into the output capacitor equation, And then value of output capacity is 10.75 pico. And then we calculate the output resistor value RL parallel to RD parallel to small RD. And then we get answer is 3.197 kilo ohm. So value for the frequency after substitute the value 4630.94 kilohertz. So for this question, the dominant high cutoff frequency is FHI 62, which is 625.77 kilohertz.
So for question C, the question asks to calculate the low cut-off frequency for each of the coupling CG, CC, and bypass CS capacitor and identify the dominant cut-off frequency. First, we need to find the cut-off frequency due to CG. By using the formula FFG equals to 1 over 2 pi R plus RA CG, by assuming RA equals to RG1 parallel with RG2, we will get RA equals to 99.10 times to 10 power of 3 ohm. Then by having the result of RA, we can calculate R plus RA equals to 109,100. Then we have all the information. We just subtract into the equation FLG and we will get FLG equals to 1.46 Hz. Next, we will find the cutoff frequency due to CC. Same equation with the above. FLC equals to 1 over R pi RO plus RL CC. By assuming RO equals to RD, parallel with a small RD, we will get, by assuming RD equals to infinity, then RO equals to RD. RO plus RL, we will get 14,700 ohm. Then we have all the information, just subtract into the formula FLC, and we will get FLC equals to 21.65 Hz. Next, we will need to find cut-off frequency due to CS. This time we will use the formula FLS equals to 1 over 2 pi R equivalent CS. By assuming R equivalent equals to, by using formula R equivalent equals to RS parallel with 1 over GM and RD is equal to infinity. We can find 1 over GM since RD is infinity. 1 over GM, we will get 399.68, and we just subtract to the equation of R equivalent, we will get 299.82 ohm. Then we just subtract the value of R equivalent to the FLS equation. Then we will get FLS equals to 241.29 Hz. Dominant low cut-off frequency is FLS equals to 241.29 Hz. In the question asks to find the low frequency response, then the low frequency response is FLS equals to 241.29 Hz. Okay, so now I'm going to talk about the importance of analog in the current technology trend and example of its application. As we all know, in the past few decades, we are moving towards digitalization. In today's time, everything seems to be digital, from watches to radio players, camera, cell phones, and even books. However, people accept digital things easily enough, often by thinking of them as electronic, computerized, and perhaps not even worth trying to understand. Analog technology is the measurement of the analogy time or length. For instance, if you measure the length of your thumb and mark it on the surface of a ruler, then that little segment of the ruler is of the same length as that of your finger. Hence, it is known as the representation of your finger. Analog technology not only signifies the measuring instrument, but it signifies everything that is not digital. The analog technology does not involve any electronic representation of numbers. The old film cameras and cassette recorders are the best example of analog technology. Some examples of analog technology are signals. Analog is an electronic communication sent as signals of varying frequency, while digital signals communicate a binary value such as on and off or 1 and 0. Analog signals are best represented as graphs. analog method allow the equipment to handle information that continuously changes, such as voltage, current, and wave. Next, an analog device is a mechanical or electronic device that does not use digital signals, while a modern computer works by sharing binary numerical information. Analog device convey information like sound or visual by storing it on a physical medium like film, tape, or vinyl. So, as you can see here, I have list 4 examples of analog device. Firstly, loudspeaker. Loudspeaker is a device that converts electrical energy into sound energy. A loudspeaker is generally used to increase the voice that can transmit over a long distance or a crowd place. Next, we have landline telephone. A landline telephone is used for verbal communication over a long distance, and it also transmits voice signal through analog signal only. The next example is we have audio tape and audio amplifier. Audio tape is used for voice recording and playing. It takes the voice input as analog signal and gives output in analog signal. While an audio amplifier is basically an analog signal. The main function of an audio amplifier is to amplify the magnitude of the audio signal. The last example of an analog device is an antenna. The antenna is one of the best device among the analog device example. It because it can transmit the analog signal from one circuit to another circuit over a long distance wirelessly through the radio frequency signals.
So, in conclusion, we know how to solve the question about transconductance of high cutoff frequency, transconductance, high cutoff frequency, and low cutoff frequency for this assignment. Because we have did a lot of study and research about fed amplifier, about high cutoff frequency and low cutoff frequency, and then based on the circuit given, uh, we have obtained the solution for the question, which is we get the correct value for question A, which is GM is equal to 2.5 millisiemens and JMO is 4 millisiemens. For question B, FHI is equal to 625.77 kilohertz and FHO is 4630.94 kilohertz. For the dominant high cutoff frequency, it is FHI, which is 625.77 kilohertz. Next, for question C, we obtain the value for frequency for gate capacitor 1.46 hertz, and for FLC 21.65 hertz, and for FLS is 241.29 hertz. And we have identified the dominant cutoff frequency is FLS, which is 241.21 hertz, which is also the low frequency response. And then we can conclude that objectives for this assignment has been achieved since we have solved all of the question given in this task. And then next, since this question asks the student to use fed amplifier to solve the question, we have a recommendation for future work that can be done. When the question asks the student to use BJT instead of use FET, in hope that we are able to compare the difference of FET and BJT and know how to and more confident to calculate BJT amplifier. And then that's all from us. Last is reference. This is all our references. And that's all from us. Thank you.